Good morning, class. My name is Engineer Patrick. Today, we're diving into the amazing world of indices and their laws. Are you ready to unlock the mathematical superpower of indices? Before I forget, if you are new to my channel, please subscribe by clicking on the subscribe button and hit the notification bell so you can tell when we have more content for you. Let's start with the fundamental concept of indices. Indices, also known as exponents or powers, express repeated multiplication in a more compact form. For instance, 2 to the power of 3 written as 2 to the power of 3, which is 2 multiplied by itself 3 times. And this is equal to 8. Let's look at the 2 to the power of 3, note that the base here is the 2 and the power is 3. Let's look at another example. b to the power of 4. This means that b is multiplied by itself 4 times. Now, to make our lives easier, we have some fantastic laws of indices that help us manipulate and simplify expressions involving exponents. Let's explore these laws one by one. 1. Law of multiplication. When multiplying numbers with the same base, we can simply add their exponents. A raised to power n multiplied by a raised to power m is equal to a raised to power n plus m. Examples 1. The equation a raised to the power 4 multiplied by a raised to the power 3 represents the multiplication of two numbers with the same base, which is a, and different exponents, one is 4 and another 3. To simplify this expression, you can apply the multiplication law of indices, which states that when multiplying two numbers with the same base, you can add their exponents. In this case, you have a raised to power 4 multiplied by a raised to power 3. Since the base is the same, a, you can add the exponents, which gives you a raised to power 7. Did you know that the laws of indices hold an incredible power? Understanding and mastering them can unlock a whole new dimension of mathematics. The enigma of indices is waiting to be unraveled. Indices, or exponents, are a shorthand way of expressing repeated multiplication. They give us the ability to raise numbers to any power. Two, law of division. When dividing numbers with the same base, we subtract the exponent of the divisor from the exponent of the dividend. And it is written as a raised to power n divided by a raised to power m, which is equal to a raised to power n minus m. By understanding the laws of indices, we gain the power to simplify equations, manipulate large and small numbers effortlessly, and explore new mathematical concepts. It's like holding the key to a world where calculations become elegant and efficient. 3. Law of powers. When raising a number with an exponent to another exponent, we multiply the exponents. Is written as a raised to power n bracket raised to power m equal to a raised to power n multiplied by m. Product law. When raising a product of factors to a power, you can distribute the power to each factor individually. It can be expressed as a multiplied by b bracket raised to power n equal to a raised to power n multiplied by b raised to power n. Quotient law. When raising a quotient to a power, you can distribute the power to the numerator and denominator individually. It can be expressed as a divided by b bracket raised to power n equal to a raised to power n divided by b raised to power n. Six. Zero exponent law. Any non-zero number raised to the power of 0 is equal to 1. It can be expressed as a raised to power 0 equal to 1, where a is not equal to 0. 7. Negative exponent law. A number raised to a negative exponent is equal to the reciprocal of the number raised to the positive exponent. It can be expressed as a raised to power minus n equal to 1 divided by a raised to power n. When a number has a negative exponent, it actually represents the reciprocal of that number raised to the positive exponent. Negative indices allow us to work with extremely large or small numbers with ease. By understanding the laws of indices, we gain the power to simplify equations, manipulate large and small numbers effortlessly, and explore new mathematical concepts. It's like holding the key to a world where calculations become elegant and efficient.